In this video, we'll be talking on the application of differentiation to calculating velocity and acceleration. Now, if a body moves a distance x meters in time t seconds, then the distance is given as x in a function of t. Now, velocity is the differentiation of the distance, that's the x dt or f dash t, and acceleration is given as the second differential of the distance or the differentiation of the velocity. So this brings us back to successive differentiation. So to get velocity, we differentiate distance. To get acceleration, we differentiate velocity. Now, we have two questions. The question one says a distance x meters moved by a car in a time t seconds is given by this function. We have to determine the velocity and acceleration when t is equals to 0 and when t is equals to 1.5 seconds. So we're given x to be equals to 3t cubed minus 2t squared plus 4t minus 1. So the first thing to do when we want to evaluate velocity is to differentiate distance. Okay, so velocity differentiating x will have 9t squared minus 4t plus 4. The unit of this is in meter per second, because the unit of the distance given is in meters. And now the acceleration is differentiating it the second time, and that will give us 18t minus 4, and the unit is meter per second squared. Now, having done this, we are asked to evaluate the velocity and acceleration at t is equals to 0 and at t is equals to 1.5 seconds. So when t is equals to 0, the velocity is the x dt at t is equals to 0. So wherever we see t, we substitute 0. So that is 9 into 0 squared minus 4 into 0 plus 4. Remember, the unit is in meters per second, and our answer will be 4 meters per second. Now the acceleration, which is the square x dt squared at t is equals to 0. So for the expression of acceleration, wherever we see t, we put 0, and the unit is meter per second squared, and this will give us minus 4 meter per second squared. Now the same thing is applicable when t is equals to 1.5 seconds. We can calculate our velocity, which is the x dt at t is equals to 1.5. So wherever we see 1.t, we put 1.5 minus 4 into 1.5 plus 4 meter per second, and this will give us 18.25 meters per second. And our acceleration at t is equals to 1.5 will be 18 into 1.5 minus 4, the unit being meter per second squared, and we'll have 23 meters per second squared. So now we want to solve the next example. We say supplies are dropped from an helicopter And the distance falling in a time t seconds is given by x is equals to half gt squared, where g is equals to 9.8 meter per second squared. Determine the velocity and acceleration of the supplies after it has fallen for a time 2 seconds. This is similar to what we've done before. So you can pause the video right away and try to solve this. Okay. We were given that x is equals to 1 over 2 gt squared, where g is equals to 9.8 meters per second squared. X is the distance. So the distance x, substituting the value of g, that's 1 over 2 into 9.8 c squared. Okay, and that will give us 4.9 c squared, the unit being meters. Now the velocity v is the x, the t. Now that means we're going to differentiate 4.9 t squared, and that will give us 4.8 t, the unit being in meters per second. Now the acceleration a, which is differentiating velocity, which is also differentiating distance twice, you will have 9.8 meters per second squared. Now the question says determine the velocity and acceleration of the supplies after it has fallen for 2 seconds. So when time t is equal to 2 seconds, the velocity will be dx dt at t is equals to 2, that is 9.8 multiplied by 2, and that will give us 16 or 19.6 meters per second. However, the acceleration will remain the same because there is no variable t. There is no variable t here. Therefore, the acceleration is still 9.8 meters per second square, which is called acceleration due to gravity. In our next video, we'll look at 2 more examples on velocity and acceleration.